Euclid's postulates. Now that we have seen the 5 different postulates in Euclid's contribution to mathematical society, now comes what are the uses of these postulates? Where do we use them? What are the significances of the 5 postulates as we have learned in the previous session? Is the biggest question which arises next. So Euclid's contribution is about his postulates which are applied in different axioms, theorems or various properties in mathematics. So let's see few of the properties in mathematics where Euclid's postulates are exclusively used in deriving those properties. So here comes the topic applications of Euclid's postulates. So let's see the different applications of Euclid's postulates in brief. As we have seen the different 5 postulates, let me come with this property. Say I have a line segment which is divided at A, at B, and C divides the line AB. So in this case, I clearly see that the distance AC and the distance BC when added gives me the distance AB. Therefore, the property says the distance AB, the distance AC plus the distance CB is equals the distance AB, is how I derive using the Euclid's postulates. The postulate which says between 2 distinct points there is only one line which can be drawn, and therefore I have only one line which passes through A and C, which are the distinct points, and there's only one unique line which passes through C and B, which is unique, and therefore this will be a complete same line which passes through all the 3 points. You cannot draw more than one line passing through A, C and B taken in pairs as distinct points, AC and CB. So this postulate number 1, as we have discussed in Euclid's postulates, we have a property which says the sum of 2 sides is the sum of the longer side. That is, AC plus CB will be equal to AB, is how the property gets derived using the Euclid's postulates. Significance of Euclid's properties or Euclid's postulates in the branch of mathematics. Property AB plus BC will always be equal to AC if the 3 points A, B and C are on the same line as given here. A, B and C are on the same unique line. Cut. Let's see one more mathematical property which has used Euclid's postulates in its own derivation. So as we say, Euclid has used his postulates to prove that an equilateral triangle is a triangle which has all 3 sides equal, as we know. An equilateral triangle can be constructed or derived from any line segment, is how we understand the postulate. An equilateral triangle can be constructed or derived from any line segment. So let's see how we use the postulates in this. So Euclid has come out with taking a fixed line segment AB with terminated line, as he used to call during his times. He has taken a terminated line AB and then tried to construct an equilateral triangle using this dimension AB. Therefore, he has come with the measurement and then used the circle property to construct an equilateral triangle from a line segment. The circle property, as he has defined that any circle with any radius can be formed, a circle can be formed simply by taking different radii and different centers. Therefore, he has taken a circle fixed with A and then cutting an arc. So he has made a circle passing this way. And then from this B as the center and AB as the radius, he has cut another circle out here. So there are two circles which are formed out here, cut. Now this point of intersection was taken as a third coordinate C. The two circles derived cut at one point of intersection, which is called the point C. Now as you join this and as we join this, we get an equilateral triangle. An equilateral triangle which has all the three sides equal is how Euclid has come out with any circle can be drawn with center and radius. So he derived different circles within the line segment and then the point of intersection was joined to form triangle ABC is constructed equilateral triangle because AB equals BC equals AC. So triangle ABC is constructed equilateral triangle. Equilateral triangle with all three sides equal. So in this manner, any line segment can be taken to be just intercepted and I get an equilateral triangle. I take another line segment which is smaller in size. I use the same concept of cutting the arcs and then I join to get an equilateral triangle. Or I take a very big line segment, cut an arc with the respective length of the line segment as radius and the point where the two circles intersect, I join the other two segments and I get an equilateral triangle. An equilateral triangle can be constructed from any line segment is how we understand the postulates of Euclid applied in real life situations. Constructing an equilateral triangle from a fixed line segment out here. Now let's see the theorem. Let's see how Euclid has proved a theorem using the 5 postulates which he has used in his contributed life, which he has invented in his contributed life. So let's see how the postulates have been useful in exclusively proving a new property through the contradiction. So let's see the property. To start with, Euclid's postulates helpful in deriving a theorem. So let's see how a theorem is derived using Euclid's postulates exclusively. The theorem says two distinct lines two distinct lines cannot have more than one point in common. So the theorem here says when I take two distinct lines, those two distinct lines cannot have more than 1 point in common. That is, the theorem says if I take two distinct lines which are not same, then when they are extended, obviously they have to meet at 1 point. So here, when this lines AB and CD are extended, then these lines meet at 1 point. They have 1 point in common, or they have 1 point of intersection. They must intersect, provided those two lines are not parallel to each other. So two distinct lines cannot have more than 1 point in common is how I understand the two lines intersecting. There should be only 1 point of intersection possible. So let's see how this theorem has been proved exclusively using the postulates. So the proof is by contradiction. Like, given the statement, I take the contradiction of the statement and then prove that the result of that contradictory statement is not true using the proof. So now it is given that the two distinct lines cannot have more than 1 point in common. I take this to be line 1 and this to be line 2, and I assume that let the two lines which are distinct have more than 1 point in common. So cannot is now contradicted to be can. Let's contradict the statement that is, let the lines L1 and L2 have more than, or I can say have more than 1 point. That is 2 points, 2 points in common. That is, the two lines are said to be intersecting at P and Q. Therefore, let L1 and L2 intersect at, say, at P and Q. Let L1 and L2 intersect at P and Q. Now, here comes the concept of proving the theorem. Now that we have assumed that the lines L1 and L2 intersect at P and Q, therefore, but this is not true. Why do you think that this is not true? Because we have already seen in the postulate that there's only one line which passes through the 2 points. Now here I have 2 points through which it is assumed that there are 2 lines which are passing through L1 and L2. So here in this statement it is assumed that there are lines L1 and L2 which pass through P and Q, which is not possible, or it contradicts the statement, the postulate number 1. The unique line, there's only one line, one and only one line which passes through 2 distinct points. But here the distinct points P and Q, but there are 2 lines passing through the same point. So this contradicts postulate 1. Therefore, our assumption is wrong. What is our assumption? Our assumption that the lines L1 and L2 have more than one point in common is true, is false. So our assumption is wrong, implies the original statement is correct. So this kind of proofs are called proofs by contradiction, where I take the contradiction of the given statement, the distinct lines cannot have more than one point in common. Let's take the statement two distinct lines have more than one point in common and then prove by contradiction. So contradicting the statement L1 and L2 have more than one point in common. Say I have the lines which are intersecting at 2 points, or they have 2 points in common. So we have L1 and L2 intersecting at P and Q, say for example. But this is not true, because a line, there's only one and only one line which passes through the distinct points P and Q, but we have two lines which are passing through P and Q, and contradicts postulate number 1 as discussed in the previous session. Therefore, our assumption is wrong. Therefore, the original statement is true. The original statement is true. The original statement which says two distinct lines cannot have more than one point in common. If the two lines which are distinct at the most can have one point in common, but not more than that. You cannot have 2 points of intersections for this lines intersecting. As we have already seen in the linear polynomial, the two linear polynomials intersect at only one point. This is how we connect the learned concepts in mathematics to Euclid's postulate and Euclid's contributed theorem. Theorem applied through postulates and proved mathematically.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.